Welcome back. Let's look at case 1. Directrix is x equals d. Distance of P from F is E times distance of P from L. That is R is E times d minus R cosine theta. Distributing the multiplication by E, you get R equals E times d minus R E cosine theta. Get this on this side, you have R plus R E cosine theta is ED. Get R common, you have 1 plus E cosine theta is ED. Therefore, R is ED over 1 plus E cosine theta. That's the polar equation of the conic. Now, x equals d is here. That's your directrix. X equals d. Focus is 0, 0. In this particular case, you have the following conic. R equals ED over 1 plus E cosine theta. This is presumably the picture. Looks like a parabola, right? This is when E equals 1. When D is greater than 0, we have negative D less than 0. So directrix is x equals negative D. In this situation, you have the following polar equation. X equals negative D is on the left. You have a parabola. Case 3, the directrix is y equals d. Y equals d, your situation is similar, but instead of x coordinate, you have y coordinate here. So d positive, you have a line over, and that's your curve below. On the other hand, directrix y equals negative d, line is below, curve is above the line. So notice where you had cosine earlier, now you have sine. That's the only difference. Okay. Here you had cosine below. Now you have sine. All right. First example, find polar equation of the parabola with focus at the origin directrix y equals negative 9. D is 9, E is 1 because it's a parabola. So you're simply substituting. D is positive, right? E is 1. So E is 1. D is 9. You're simply substituting here. All right. Here, this is the one. Oh, directrix is below, so you're using the last case, case 4. Directrix is below the y-axis. Likewise, you are here given a conic section given by this equation. Identify the conic. Well, it's a cosine with a negative. So you have this equation is similar to this equation. Well, you get this such an equation when directrix is x equals negative d and the focus is 0, 0. So R equals 12 over 1 minus E cosine theta. You need to rewrite it with a 1 over there. So take your original equation, polar equation, get 3 out, 3 divides. Now this is exactly like this. So E equals 4/3. Notice the arrangement. That's E. That's 4/3. And E times D is 4. So 4/3 times D is 4. That gets you D equals 3. E is 4/3, which is greater than 1. Therefore, the conic is a hyperbola. The directrix is x equals -3. You can solve for h using your formula for h. You can also find the x-intercepts. When you have a hyperbola, you can find x-intercepts as long as the directrix is perpendicular to the x-axis. Well, you have x-intercepts when theta is 0 and theta equals pi. Substituting in your polar equation, theta equals 0. That's one x-intercept, and theta equals pi gives you another x-intercepts, right? This is incorrect, right? So that's your x-intercept, that's your x-intercept, okay? So there is mistake here. This should be the other way. Likewise, this should be the other way. X-intercepts. These are your x-intercepts. Here is your axis, and that's your focus. All right. Example 3, a conic is given by the polar equation r equals 10 over 2 plus 5 sine theta. Identify. So sine, the presence of sine tells me my directrix is y equals d. Moreover, d will be the coefficient of sine. D will be obtained by the numerator. The plus here tells me my directrix is here, right? The plus tells me the directrix is above the x-axis, okay? All right, so let's see how this looks like. Get 2 common out. That gets you the 1. 2 divides the 10. That gets you the 5. Eccentricity is 5 halves. E times d should be 5. 5 halves times d should be 5. You obtain an eccentricity that gets you r, the equation. To find the you have the directrix, so you need to find the y-intercepts. You obtain y-intercepts when theta is pi over 2 and 3 pi over 2. Substituting those values, you get certain r values. So notice when 3 pi over 2, r is negative 10/3. All right. So when angle is 3 pi over 2, you go back basically. So that's the picture you have. That's one y-intercept. That y-intercept you obtain when theta is pi over 2. This one when theta is 3 pi over 2. So that's why you have gone back, okay, negative distance. All right, we'll continue in the next video.